you take out your gravity calculator. To be honest, I just picked a random page out of my 5x5s. It very well could be. Let me read it. I honestly just opened my 67-page document to a random page and hit print. Okay, let R be the shaded region bounded by the graph. Y equals ln x. On the line, y equals ln x minus 2. Find the volume of the solid when generated by revolving it around the line. Y equals 3. Yeah, it's actually not a washer, it's a disc. Okay, skip your number 1. I told you, I just printed a random page in the packet. Okay, maybe about 2 more minutes. All right, let's talk about our answer and see how we did. So these were all bits and pieces of past AP exams. They were maybe part A's, part B's, etc. I literally just used that last period. Why? Alright, so I used geometry, so I took the area of the triangle below and got -1. I took the area of the trapezoid above. I got positive 4. So g of 4 was equal to 3. G of 4 is equal to 3. Now, g prime of 4 is the equivalent then. So if you take the derivative of the integral, you get the function. So g prime of 4 is really like f of 4. And f of 4 on my graph was 0. G double prime of 4 is the same as the derivative of 4. And at this point, if you do not know, the derivative represents the rate of change. Rate of change is slope in mathematics. So g double prime of 4 is asking you for the slope of the line at 4. So they gave you the point to the right of 4. They gave you the point to the left of 4. So you find the slope to the right and left of 4, and you get negative 2. And then part 3, does G have a min, max, or neither? So then what you do is you go to the graph to start and say, okay, this graph represents the derivative. So at 1, g prime is 0. So if the derivative is 0 of a function, then it's a critical point. A critical point is a potential extrema. So now what you have to do is look at the graph. And what I see is that f changes from negative to positive. Therefore, g has a relative max. If you wanted to talk about the function in terms of g's, alternatively, you could have said g prime of 0 is less than 0, and g prime of 2 is greater than 0, also making g of 1 a relative max. And then down at the bottom, I feel like we actually looked at this question in the past. It was in our notes for 7.1, I believe. So hopefully we all got this one. Initial plus generic change in time. Amount going in, amount coming out. This is an example of a rate in, rate out, because you are given a rate to start. So this represents cubic yards of sand. Because this is sand in cubic yards per whatever it is, hours. So you're given a rate. This is like the derivative, and now you're finding the original. And I think that that's one of the errors we've been making on a lot of our FRQs is understanding which part of the function we are looking at. So what I want to do with you now is go over to the FRQs we've had the past few days. to do is, I guess we'll start with the rocket one, just because I have that paper out in front of me. So let's look at the rocket example. Sorry, I was sending Nick his. I don't know why it looks like that. So I want to just talk through it kind of briefly. So for part A, it said find the average acceleration of the rocket. So if you're given velocity, average acceleration is another way of saying the slope of velocity at that time, like over that time interval. So like you don't have a function for velocity to derive. So in order to find the average acceleration, all we were doing was looking at the change of the velocity from the beginning to the end. So the average acceleration was simply the slope of velocity, where this was y1 and this was y2. So you should have had v of 80 minus v of 0 over 80 minus 0, which was 49 minus 5 over 80. So you could have had 44 over 80 or divided everything by 4, and it got 11 over 20. The units for velocity are feet per second, and then the units for the denominator were seconds. So that made the units for this feet per second squared. But I mean, you could also have left it like that. So here's the thing. If you couldn't figure out this answer, but you could figure out your units, write a dummy number. So this was a problem where it had you indicate units in A and B. They will only give you a unit point if you have a number attached to the units. So if you tried to like write the words, which I think 2 of you did, but you didn't have a dummy number, you would actually not earn your point. I gave it to you because I was like, this is something we can talk about. But even if you couldn't get this 11/20ths, write 100, write 1, write 10. I don't care. Earn yourself your unit points by putting a dummy number right there. Those of you that didn't have a number and they tried to put words but had the units, do you understand what I'm saying now? Okay. So that was part A. Part B is a Riemann sum. So it says, using the correct units, explain the meaning of that. So the meaning of 10 to 70 for v of t dt. Well, this represents distance. So if you integrate velocity, you get distance. So it's the distance traveled by rocket A. And then it asks for the units. So if you integrate velocity, and velocity is feet per second, then this is in feet. From, and you could have said 10 to 70 like this as an interval. You could have had it in bracket notation, or you could have said from t equals 10 to t equals 70. Okay? Now, the Riemann sum. We are still kind of goofing up our Riemann sum, so let's look at this table. It says use a midpoint. So that's MRAM. With 3 subintervals. So that's my N. from 10 to 70. So that's my A and B. So my dx is equal to 70 minus 10 over 3, or 20. So my dx is 20, so that's my width of each rectangle. Now I need to find the heights. So we're talking about 3 subintervals from 10 to 70. So we're completely ignoring the 0 and the 80. So I have 1, 2, 3, 4, 5, 6, 7 intervals. And I need 3 equal ones of distance 20. So I can't split it. I can't go 1, 2, 1, 2. That doesn't work. So then you have to almost imagine this a little differently. So if it's 60 as my total width, and we divide 60 by 3 and get 20, I need to go from 10 and up 20, which means you go to 30. 20 up from there goes to 50, and then to 70. So in the middle of 10 and 30 was 20. In the middle of 30 and 50 is 40. And in the middle of 50 and 70 is 60. So you needed to go in the middles of all your 20s. So all my rectangles are with 20, and I'm in the middle of each. So that meant my heights were 22, 35, and 44. And to get that final number, I probably would have added all of those together and then multiplied by 20, because multiplying by 20 is kind of like multiplying by 2. So like 44 and 22 gave you 66. 66 plus 30 gave you 96. 96 plus 5 gave you 101. And then you just had to multiply that by 20. And you got 2020. And again, my units are feet. So even if you got this number wrong, but you got your feet here and your feet per second squared there, you got a unit point as long as you had a number attached to each. So obviously the 2020 is right, but if you didn't have 2020, you could have still earned your unit point. That was 5 of the 9 problems on this point. Part C, a little bit more complicated. So it says rocket B is launched upward with an acceleration of 3 over square root t plus 1. A lot of you auto-brought that t plus 1 up as a negative. Some of you even changed it to a u. All of that was fine. At time t equals 0, the initial height of the rocket is 0. And this is where we goofed up. because you treated S of 0 equals 0, like the initial condition of velocity, but they told you the velocity at 0 was 2. Said which of the two rockets is traveling faster at time 80? So rocket A had a velocity of 80 at 49, and we got that from our table. And then the rocket's velocity at 80 here, well, you needed to find the integral of A of t dt to find velocity. So for, this is rocket B, it's antiderivative. You could have pulled out your 3. And this is where some of us did U sub, which it didn't matter too much because the derivative was 1. So it didn't affect your U sub if you didn't. But you got 3, add 1, and divide by 1/2, and our plus C. So that gave the velocity of the rocket, but then we needed to find what C was equal to. So you use the initial condition of 0. So V of 0 was 2. So you got 6 square roots of 1. So you had 2 equals 6 plus C. So you got -4 was equal to C. So then V of B at 80 was equal to 6 square roots of 80 plus 1 minus 4. Well, 80 plus 1 is 81. 81 square rooted is 9. 9 times 6 is 54. Minus 4 gave 50. So the velocity of rocket B at 80 seconds was 50. The velocity of rocket A at 80 seconds was 49. Therefore, rocket B was traveling faster at t equals 80 than rocket A. Is everybody okay with that? Because we were kind of all over the place with this problem. I was surprised because we had done PVA the day before, where we actually looked at one just like this. Questions, comments, concerns? Again, I can't help if I don't know. One of you asked me for a Riemann sum. Somebody else asked me for a derivative. I have a FRQ we're going to go to next that covers both. Well, I can't help if I don't know. Okay, so the other FRQ I gave you, this FRQ had an average of a 6 to a 7.2, the Joanna walking one. So let's go over our answers for that. So for this one, I was actually really surprised how many of us lost our minutes squared. Units weren't actually worth any points. But again, here's another example where you're finding the derivative using a table, using slope. Part B, here's another Riemann sum. Now if you look at part B in this problem versus part B in the other problem, This one has an absolute value around our velocity. Therefore, it changed the wording to total distance, not just distance. Yes, I know what you should say. See, what upgrades them? I actually know like what you guys rate. Still pay attention to it later. Like I know who missed what. Okay. It sits with me. Hey, what's up? Hi. Yeah. Oh, I'll let her know. You're very welcome. Hi. Alright. So the difference between those two is the absolute values. So that made me start to think like somebody had displacement, aka Carson called out on that one. But like the difference was the absolute values, and I would think without them, even though their answer key in the previous one had distance, displacement is distance without absolute value. So this one, however, because of the absolute values, you could not utilize displacement. You had to have total distance, and this one's more specific towards that. It also, guys, this was the biggest, it made me sad grading them. Your biggest error was that we had the absolute value bars, so we were looking for total distance, but then you plugged in a negative. I can't tell you how many of you, and that's exactly what they were checking you on. They were saying, okay, do you get it? Do you get that the absolute value of velocity is going to change? All of the velocities in that table, I don't even have the original. It's going to change all the velocities in that table to positives. How many of you put the negative and now you're really mad at yourself because that was an easy fix? Yeah. So fix. Like that's what we're doing all of these practice for. To correct and help us make those mistakes not on Tuesday. Okay, derivative earned you a point, and your answer earned you a point. If you didn't have the derivative, but you had b prime 5, still got it. Okay, I can't tell you or stress enough. Average means you have to have a dividing by 10. I also can't stress enough how many of us either didn't take the integral and plugged into the original, kind of etc. Yeah, kids are weird. Okay, does that feel better for that? I'm going to let you guys go out during the bell then because I know the bell rang. Caitlin, your shirt's in the office if you want to go grab that. I'll see you guys back here in 4 minutes. So go ahead, take a minute, read through that paragraph at the top. I'm actually going to give myself more space. Great. So as I read through that top paragraph, here's the key things I pulled out. I said, okay, my table's the derivative. It's kind of like being given the graph of the derivative. This is my rate of change. If I go backwards and find the areas, then I get the rate. If I go forwards, then I find the acceleration. I was given an initial condition. R of 5 is 30. R of t is feet. That makes sense. If you integrate feet per minute, then you're going to just end up with your feet because you're getting rid of the per minute. And then I'm also told that the derivative is, or the original is concave down always, which tells me that the second derivative is always negative. That might come into play if I get asked about if it's speeding up or slowing down. I love that they gave me the geometric equation because you don't have to worry about memorizing that. Part A, estimate. So we don't know the real function. We can't find the real answer. So if we want to estimate the radius of the balloon at 5.4, you are finding the slope of the derivative around 5.4. We know 5, that's 30. So this is fundamental theorem of calc. Or you can even kind of think of it as like linear approximation. R of 5.4 would equal my initial condition, or R of 5, plus we want to know R prime of 5.4. And then take into account x minus 5. And then this x here is the x we're trying to find, which is 5.4. Sorry, I have my document camera. So what we don't know is the slope. But we know the slope really, really close at 5, just like we know the initial condition at 5. So the slope at 5 is 2. So this is an equation of a tangent line used to find 5.4, aka linear approximation. So it's 30 plus 2 times 0.4. Which is 30.8 feet. So I've estimated the radius at 5.4 using my linear approximation at 5. Is your estimate greater than or less than the true value? So here is where concavity comes into play. If the original function is concave down, doesn't matter if it's concave down and decreasing, or if it's concave down, dude, it's totally concave up. Sometimes I can't speak it, right? So concave down and increasing, or if it's concave down and decreasing, the equation of the tangent line in either situation is always going to be where? An overestimate. So it doesn't matter if it's increasing or decreasing. based on the idea that it is concave down, and that's why I drew both scenarios, we know that R of 5.4 is an overestimate because the graph of R is concave down. So the estimate is greater than the original. Okay, part B. Find the rate of change of the volume of the balloon with respect to time when t equals 5. Indicate units of measure. So if we're looking for rate of change of volume, we're looking for dV dt. So derivative of volume we're looking at t equals 5. Does anybody know what dr dt would be? 2. Excellent. Because it's the rate of change from the table at 5 seconds again. So what would my volume derivative units be? Oh, sorry. At time 5, my radius is 30. Sorry, I meant to write r of t. So it's actually 30 squared. So I can't write and speak without having. You don't have to, and by the way, you don't have to change this to a number. Like you could write over here 8 pi times 30 squared. Like if you don't know what 30 squared is, you don't have to fix it. Now 30 squared is not bad because 30 squared is like 3 squared, but you add some zeros. But again, so it's 900 times h, which is 7,200. My units, though, these are a little trickier. So if radius is feet, we've squared our radius, so you have feet squared. dr dt is feet per minute. Therefore, my units are feet cubed per minute, which should make sense because it's dV dt. Velocity is cubic and time. Here's our Riemann sum. So 5 subintervals from 0 to 12. So dx is 12 over 5 Now, in this case, are my intervals in the table even? No. So my dx would be 12 over 5 if my intervals in my table were even, like they've been for some of our past. But now this one's actually a lot easier. We're just going to make 5 rectangles. From those data points. So you have a rectangle with 2, 3, 2, 4, and 1. And it wants a right. So what's on the right? This point, this point, this point, this point, and that point. So my RAM is 2, 4, plus 3, 2, plus 2, 1.2, plus 4.6, plus 1 times 0.5. So 19.3 plus 14, 15, 16.8, 16.8 or 16.4 plus 2 more gave you 18.8 plus 0.5 gave you 19.3. And again, if you're finding the integral from 0 to 12 of r prime t dt, then that's equal to what? Because it asks you, using correct units, explain the meaning. Yeah, it's the rate of change of the radius in feet, perfect, from 0 to 12. And just because I see that using correct units, I am probably going to go back and make sure on my 19.3, I throw in feet at the end of it. So I'm going to tack on units here. Okay. Part D is my approximation in C greater than or less than the actual. So these data points are all positive. So the derivative is positive. So if the derivative is positive, then the original is increasing. So my graph of my original is increasing and concave down, which means it's this example here. So if my graph is increasing and concave down and I do right Riemann sums, Our right Riemann sums for increasing and concave down going to be over or under estimates. Are my rectangles above or below that line when I drew them on my little graph sketch? Or over, yeah, because they're all above. So do you see how being able to give yourself an idea of what the graph looks like allowed you to answer parts A and B? So since R is concave down and increasing, so what I want to do is give you guys, so we have about 20 minutes. I'm going to give you 10 of those 20 minutes to try the first 10, So 10 minutes at 2 minutes of multiple choice would mean 5. So try the first 5 multiple choice questions. Yes, because from the non-calculator part of the exam, yes. They're all non-calculator.
Sorry. I went to AP Classroom. It's an idiot.
Okay, about 1 more minute. All right, so let's go over our answers and see how we did. Number 1, the answer is B. So the answer is B because what you had to do was find your antiderivative. So x cubed over 3 minus 2x squared over 2. Your 2's canceled. And you evaluated from 3 to negative 1. So it's 3 cubed over 3 minus 3 squared minus negative 1 cubed over 3 minus negative 1 squared. So here, anything squared is positive, so that negative 1 was really like 1, but a negative 1 cubed stayed negative. 27 divided by 3 was 9. 9 minus 9 was 0. Negative negative became a positive 1/3 plus 1. Okay, number 2. So in number 2, the correct answer is D. Derivative is a product rule. So it's first times derivative of second plus second times derivative of first. And then you have to plug in 2. So E's matched. 2 times 9 is 18. Thank you, Fab. Sorry. No. There it is. That's what I get for trying to go fast. Okay, linear approximation. Linear approximation says L of x equals f of a plus f prime a times x minus a. So in this case, we are trying to approximate 2.1. A is my original x, which is 2. So f of a is 4. F prime of a is negative a half. X, remember, that's the 2.1 minus a, which is 2. So you get 4 minus 1 over 20. So again, process of elimination, can't be C, can't be D. 4 minus 1/20th is never going to be A. So even if you didn't know 1/20th was 0.05, you could process of elimination to answer choice B just based on the size of the decimal decrease. Okay, G is our function. How many extrema does G have? So what you have to do is find your derivative. So the likelihood, if you have a repeated root, that we're going to end up seeing it as an extrema is slim. Happens very rarely, so anticipate that there's only going to be one. But we always want to make our number line and check. So if you plug in something less than -4, say, or less than -3, like -4, -4 plus 3 is -1. This will always be positive because something squared is positive and 4 is positive, so positive, negative becomes a negative. Plug in -1. 3 minus 1 is 2. Positive, positive, positive. Plug in +1. 4, positive, positive, positive. So it's going to go decrease to increase to that weird little increase again. Therefore, 1 extrema. Okay, velocity of the particle is given by the function below. What is the average velocity? So if I'm asking for average velocity, are we going forwards or backwards? Am I integrating or am I using the slope? Well, other way. I'm integrating. The slope would give me the average rate of change, which would give me your average velocity. So this becomes 1/2 antiderivative. So 2t minus t cubed over 3, evaluated from 3 to 1. If I integrate velocity, but then I take the average, so this right here is time, and this is feet. So you're going to have feet per time. So it's going to give you average velocity. It's like the opposite of MVT. It's like the MVT of integrals. So it's going to give you the average velocity using the change in position over a change in time. Does that make sense? Think about the integral. You're right. The integral gives you position. But because I have the change in time in front of position, the integral is going to give me the change in position, and this is going to give me the change in time. So you're going to have change in position times 1 over change in time. Okay, guys, your homework's on AP Classroom. You're good to go. If you wanted to know the answer, it was C. Sorry, I didn't get to finish. Thanks for putting your packets back here. We'll pick up with them on Monday. You can keep your answer page. It doesn't do you any good. You don't have the questions.
Malia Fermanic, please report to the office. Malia Fermanic, to the office.
Was that her last name? I really thought she said Malia from Amic. Like a person from somewhere. Yeah, that's all what I heard. But like now I get it. Like I heard to hear it again. But